All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be learning about Altair. We explored Altair a little bit in the past stream and in the previous stream, and well, I am interested in it now. I've been doing more research. Actually, I spent a good chunk of yesterday after yesterday's stream. I spent a good chunk of yesterday trying to understand what the entire workflow would be like, and I'm kind of glad that I did do that because I had a major misconception. I was making a wrong assumption. I'm gonna go into it once I've started this installation. So just give me a second here. Uh, Pip install Altair all. Okay, Altair can be installed along with all its optional dependencies. If you are using the Conda package manager, no, I'm not. At this point, you should, you know what? Okay, I'm gonna just do that. Then what else I need? I need VL VL convert. I'm gonna talk about all of this stuff. And additionally, I also need polars. So I'm gonna open up the polars docs. Does this? I think it leads to the same thing, right? Okay, let's open this up. Okay, from here we will go to Python. And is there yeah, there's a dark mode. Great, awesome. Where is the installation section? Go to the user guide, and here there should be the installation. No, it's not. Okay, there, installation. So for Python, we are looking at this. I don't remember the thing about RT compa. Actually, I don't think. Oh yeah, I do need this. So like, if it's an older CPU, this specific instruction might not be supported. Um, this is, I believe, one of those vector instructions. And while I do have CPUs that do support vector instructions, I don't know if because there's different like over time they've had different versions of the vector instructions, each one improving on the other one. I don't know which one I have supported on this machine specifically, so I'm just gonna hold on. Give me a second. Polars RT compat. I'm hoping that these double quotes will help. Let's see if that works. Okay. Okay. All right. Seems to be working out well so far. And holy shit, dude, this is so fast. This is insane. This this is so fast. The only limit here, the only limiting factor is my internet speed, which is why you can see the download is taking time. But once the download finishes, the installation is like in the next 1 or 2 seconds it'll be installed. Watch what happens when the thing completes. um I'm also realizing that I'm putting a load on my connection, which I probably should. Oh, give me a second. Hello Zaynar, welcome to the stream. Sorry, I wasn't expecting anyone to stop by the stream so early. um Hello, how's it going? Thank you for stopping by. Hey mate, glad to catch you early this time. Gotta go make some lunch, but we'll be back around. Hell yeah, hell yeah. Number one fan, I appreciate that. I appreciate that. You, yeah, sure. You take your time, finish making your lunch, and then I'll be streaming for the next hour probably. I unfortunately started the stream a little late, so I can't stream for too long today. But I want to get whatever progress I can make. I'll take it. So, okay, our thing is done here. Now I'll open up this project in NeoVim, and here I'll create a new thing called pi01.py. Okay, let's just do print hello world to get this thing started. Something is missing here. Yeah, something seems off here. Give me a second. Okay, there it is. Okay, so between yesterday and today, I've actually been doing a bunch of research on various things. Like, oh, actually, hold on, wait. Sorry, I just noticed that the RTMP feed is not there. Okay, cool. Right. Between yesterday and today, I've been doing a bunch of research on Altair, trying to understand what's going on. I was still kind of confused about what Vega Lite was, and then I did research and I found out that apparently Vega Lite is a way to specify what your sorry, the Vega language itself, it's essentially a grammar. It's a syntax that has been developed to allow you to specify what uh, it allows you to specify how this entire plot, for example, or graph or whatever is going to be built. It allows you to specify all of the various, moving parts, all of the parts that this thing is made of. Hold on. Yeah. Vega allows you to fully specify all the various parts that your plot is made up of. Um, the thing is, while that's great, Vega is how do I put this? Vega is a very descriptive syntax, and if you're writing if you're trying to do plotting work, you really don't want to be writing in Vega. You want something else to write the Vega syntax for you. So that's where Vega Lite comes in. Vega Lite is a much more lightweight syntax of Vega, and with Vega Lite, while with Vega you specify everything about how the drawing is meant to be done. With Vega Lite, you just specify what you want drawn and you give a couple of extra instructions, a couple of extra like descriptions and stuff, and then an engine handles the rest of it. And an engine basically expands this Vega Lite into Vega, and then that same engine or maybe another engine is gonna render this Vega code into some sort of plot or interactive map or whatever. So that's apparently how this is supposed to work. Now, where does Altair, or sorry, I'm so used to saying Altair. Where does Altair fit into all of this? Altair gives you a Python syntax which you can use to, describe your plots, your graphs, and then Python, or well, the Altair library, which is written in Python, the Altair library is going to convert that into um, it's going to convert that into Vega Lite syntax. What you're then supposed to do is feed this syntax into some sort of engine. And that's the part that I didn't know, because I was assuming that similar to Matplotlib, there's going to be a backend provided where it's going to render out to a PNG, or maybe it'll open up a new GUI window and then the image will be present there. No, apparently this is meant to be opened in the browser, and then there's a bunch of JavaScript stuff that happens. All the stuff that I was talking about with, expanding the Vega Lite code, which is all JSON, by the way. If I'm not mistaken, I'm trying to remember if, yeah, I believe both of them. Yeah, Both of them are JSON. Vega Lite and Vega are in JSON. So usually how it works is that you load this up along with you load up your Vega Lite file along with some sort of engine that's going to be parsing all of this. Then that's going to expand your Vega Lite code into Vega code, and then there's going to be an engine that renders out that Vega code onto the screen. The thing is, all of this is browser stuff, right? I'm not trying to do browser stuff. I wasn't even necessarily looking for interactive stuff, at least not for the time being. Maybe when I am looking for interactive stuff, then I can, explore the browser route. Though I don't think that would be necessary either because of this other tool that I found. Um, what was I saying? Yeah. Okay. So um, now through the Altair library, we're going to be able to produce the Vega Lite code that we need by defining what our graph is supposed to look like, what data it's supposed to visualize, and what extra little properties we want. Basically, we are describing what our graph is supposed to look like, but we are describing it in Python, and then the Altair library is going to convert this into Vega Lite code, and it can be exported out to a file. Um, Now, further from that point, we can use a tool called VL Convert. And this is an official tool. Like this is if we look here, hold on. Uh okay, close this. And this is it. So this is, by the way, a Rust-based tool, which is just for me, that's a gold mine. For me, that's amazing. This is a Rust-based tool and library. So what it does is it provides you, or the devs here have provided both a CLI and a Python library. The CLI can be installed. The CLI would be a binary. The CLI can be installed, and if you have a Vega Lite file, you can then feed that into this, and then you have a bunch of commands here that you can use to export your thing. So here, oh, voice crack. Here it mentions both Vega Lite specification and Vega specification, and you have similar options for each of them. Um, Actually, I need to look into what this scene graph option does. But yeah, I'm mainly interested in PNG and actually actually JPEG, not even PNG, but having the option there is great. Also, this is great, the fact that we have a PDF option. Um, they also mentioned something about a server. I haven't looked too much into that. I'll be looking into that, but this is the binary. Uh, this is the binary if you want a tool that can be used outside of Python code. So if you have something else that has exported Vega Lite code, or well, here it also mentions that it can convert Vega code. If you have either of those things, you can then use this. Um, Sorry, zoned out for a bit. You can then use this tool to convert that specification into an actual, rendered chart or graph or whatever. And then down here, there's this option called serve, which says it'll run an HTTP conversion server. I need to look into what this does. I haven't installed the tool just yet. What I wanted to do is use the Python library that they have. And I believe the Python library also it calls into the Rust code because the entire VL convert library is it's majority Rust from what I can see here. You can see like 90% of this repo is all Rust code. So my guess here is that this um sorry, I'm losing track of what I'm saying. My guess here is that this is a Rust library, and Python bindings have been created so that the Python code can call into this Rust library to do various tasks. And that's great because this way you're able to get the speed of Rust and the concise syntax of Python. This actually got me re-interested. This got me interested again in how do I say that? This kind of reignited my interest in trying to interface between Python and Rust. Um, I might do that at some point because I was doing some research with Gemini about that, and I'm interested. I'm interested because there are situations where you don't necessarily always want you don't necessarily want to write very verbose Rust code, but you do want Rust's crazy memory, crazy speed, right? But you don't want to write the very verbose Rust code, so you can then write the library in Rust and interface with that library using Python. Now, I'm saying this right. It sounds okay, or how do what am I trying to say here? On paper, this idea sounds great, right? But when you do it practically, then there are a couple of things you have to watch out for. Um, because there's certain limitations within Python itself that Rust has to work with, and there's certain default things. Like, for example, I found out that apparently when you are interfacing with a Rust library from Python, you're still going to be affected by the GIL, the global interpreter lock. And it turns out you can unlock it from the Rust code, but I haven't gone too deep into how all of that works. But yeah, keeping that in mind, you do have like certain limitations that you have to work within. You also have limitations of like, oh, how are you dealing with the data? Are you moving data from Rust to Python and vice versa? Or if the data is big enough, then are you dealing with pointers instead? Because the pointer method would be a lot faster, but I'd imagine it would also be a lot more complicated. Um, because you're dealing with memory, you're dealing with data that's handled by Rust, but you're trying to deal with it from the Python side. Okay, now all that being said, that is why I've created this new project, and I've installed, you know, um, Altair and VL convert Python and polars. Let me just confirm that the polars thing is working. What is it? Import? Yeah, import polars as PL. I haven't. Holy shit, dude! I need to like remember all of my Python stuff. I've been dealing with Rust so much lately that, or I should say, I've been dealing so little with Python lately that I'm slowly forgetting the same. I don't think I'm forgetting it though, to be fair. It's just one of those things where I have to kind of remind myself, hey, this is what it is. Okay, so this is a data frame. Let's say A, 1, 2, 3, 4, and then B, um, yeah, same thing, 5, 6, 7, 8. Okay, if this works fine. Hold on. Can I get this to respect the trailing comma? Yes, okay. I like that when I put the trailing comma there, it erased the trailing. Oh, no, it didn't. Okay, okay, no, 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 it didn't. My bad, my bad. It did exactly what I was asking it to do, which it squashes the thing if you don't have a trailing comma, and if you do have a trailing comma, then it expands it. Uh, but hold on. There are situations where even if you specify a trailing comma and the formatter determines that it's not going to be it's not going to be that long. If it gets squashed, then the formatter will squash it anyways, and it's like, you know, at that point, it becomes kind of pointless to put a trailing comma there. I have noticed this thing, and I'm kind of glad I'm not complaining about it. It's a tiny little quirk that I have to, you know, work within the limitations of. I don't mind it though, because these tools make your life a lot easier. I like it when, you know, formatters, they literally format the entire code. So if you have inconsistencies in like spaces here and there, uh, it'll take care of all of that. It'll make everything uniform. There is one downside, which is the squashing thing, but to be honest, other than this one downside, I haven't seen too many other downsides. And I'm talking about something like Rust. In Rust, you have like very specific formatting that gets done. I haven't seen too many downsides. I've seen upsides. Like I like the way that the formatter does its form there. And again, it's this squashing thing that sometimes can become a bit of a headache. Um, but it's kind of a mix of things because I also display, um, I can't show it here unless I maybe make an error somewhere. Let's do this. So you have this. This is called this is diagnostics. So I can disable this, right? This takes up a certain amount of space on the screen, and in Python this doesn't show up. Um, but I can tell you about it anyways. There's something called inlay hints. How do I how do I do that? Hold on. Let's No, Python is dynamically typed, so it's not gonna try and bind a value to this. Or it's not gonna try and give you a fixed data type. Though, I mean, why not? Let's hold on. Let's say a equals 5. I don't know what happened there. Okay. And okay, inlay hints were disabled for some reason. I'm not sure why. Let's say b equals 5.0. It's still not showing the thing. I am curious about what inlay hints is going to show and what all I can enable on the Python side. Like on the Rust side, we have inlay hints with words. Oh my God. On the Rust side, we have inlay hints that show the data type for a certain variable, or if it's a closure, it'll show the um, the trait, I think, of that closure. The signature, I'm not sure what to call it, but there's three specific things. There's fn, there's fn mute, and fn once. Fn is basically just a function. Fn mute, uh, it, fn mute means that it captures a variable from the outside context, but doesn't move it. It just captures it, gets a reference to it, and then within this function you are changing what the variable's value is. So you haven't moved it into this closure that you're building, because if you moved it, now you wouldn't be able to use this variable once the closure is over. And keep in mind, you captured this variable from outside the closure, right? So this is fn mute, where you don't move, you just borrow the thing mutably, and you make whatever changes. And then you have fn once, which is where you actually move, you capture the variable from the external context, um, or from the surrounding environment. I'm not sure what terminology to use there, but in fn once, you basically move the variable, you move the value into this function, meaning once this function exits, that's it. The variable is cleaned out. You can't use that variable, even if, you know, after exiting the closure, you go back to your context that you were initially in. You still can't use that variable because you've already moved it. That's why the function signature is called fn once. Give me a second. Okay, so back to this. We have installed VL convert, and we have also installed polars. I was supposed to check the, oh God, I did something wrong here. Give me a second. Okay, all right. So this is done. Let's print df01 just for the sake of printing. Df01, and then Python 3.13 py01.py. This is our data frame that we've made. Okay, now let's go into Altair. So this is our installation, installing Altair in so-and-so environments. I don't think I need to look into this right now. Yeah, I don't think I need to look into this right now. Basic statistical visualization. Okay, this tutorial will guide you through the basic process of creating visualizations in Altair. First, you will need to make sure you have the Altair package and its dependencies installed. This tutorial will assume you are working with a Jupyter Notebook user interface, such as Jupyter Lab, Jupyter Lab, Colab, or VS Code, so that plots are automatically rendered. If you are using another interface, you may want to read about how plots are displayed before proceeding. I actually didn't read this part. And to be fair, I hadn't even gone through the tutorial section. So far, I was just having conversations with Gemini about this. Um, Now, what do they mention here? So I'm not using any of the stuff that was mentioned over there. I'm not using Jupyter Lab or Colab or VS Code. Within VS Code, back when I used to use VS Code, I used to use Jupyter notebooks. So this says Jupyter Lab, right? Jupyter Lab. That's also one way to work with Jupyter notebooks. But VS Code also has support for Jupyter notebooks, and there's all of the Jupyter niceties come along with it, such as being able to render various types of graphs. I'm guessing Altair also has support in Jupyter notebooks, which is great. I fortunately had this conversation with Gemini, and I'm aware that I am going to need a different way to render it, which is why we are using VL convert. So according to this Python code, so we're not going to be writing this. We're going to be getting the spec from our export after we have, uh, described the graph and then exported the thing. We'll get it, and then these are our 3 lines of code that are supposed to export this to a PNG file. And then additionally, I just remembered this. I need to import OS. And for the sake of testing what this looks like, let's do os.system, um, str or bytes path, ls. What does that look like? Yeah, there you go. So all I would need to do is do westterm img cat img01.png. This is what our image is going to be. Right now, it should throw an error. There you go. We don't have an img01 for now, but with our, VL convert, we're gonna have our PNG. Okay, all right. Back to this. I can read this after stream, the displaying Altair charts. Who knows? Maybe I might get, you know, an easier way to display the charts. Okay, here, okay. There's something called Interact. Interact cannot display HTML outputs natively. Okay, displaying in VS Code. Then there's dashboards. I'm not doing any of these things because a bunch of these things involve hosting a server. I mean, granted, it would be hosted locally, but I'm not trying to do that. I just want a simple thing that I can use to render out, because for the time being, I'm not doing interactive charts. I'm mainly doing static images. Okay, working in environments without a JavaScript backend. There you go. That's what I'm looking for. The Vega Lite specifications produced by Altair can be produced in any Python environment, but to render these specifications currently requires a JavaScript engine. So this is what I was talking about earlier, where you need something that's gonna expand the Vega Lite code into Vega code, and then that Vega code has to be rendered. So there has to be some engine or a group of engines that does all of this work. Um, okay, for this reason, Altair works most seamlessly with the browser-based environments mentioned above. Even so, Altair can be used effectively in non-browser-based environments using the approaches described below. Okay, static renderers. Wait a minute. The PNG and SVG renderers rely on the JavaScript um, engine embedded in the VL convert optional dependency to generate static images. When I installed Altair, hold on, because I installed, wait, how do I see my pip freeze? Let's do pip freeze, uh, put that into bat. So we have Altair, Altair tiles, okay, go down here, PSTQR, oh, V. PSTQ? No, PQRSTU. What happened to my alphabets? PQRSTUV. So VL convert Python. I'm guessing this is, yeah, I'm guessing this is what would get installed if I even if I hadn't installed VL convert. I wonder if I can see that over here. It doesn't, no, it doesn't mention the like extra messages. That's okay. That's okay. I know that it uses VL convert, so that's great. Then we have alt.renderers.enable PNG. Okay. And then scale factor. All right. So then what's the code over here? Here it's VL convert, right? But then over here, right, how are we doing the export? Because it seems like over here I'm able to access this from through alt.renderers. I keep switching between alt and alt because I'm used to saying alt for ALT, but then this is called Altair apparently. Um, yeah, whatever. Altair as ALT. Or does this have Altair dot? No, no. Okay, we're good. We're good. Um, then over here we have ALT dot renderers dot enable PNG scale factor. Wait, am I missing something? Oh, we just provide whatever. Okay. Any additional parameters will be passed to the plugin as keyword arguments. All right. Dude, I completely forgot about this thing. Um, wait, am I supposed to be passing this in as a dictionary then? I don't think so. No, I don't think so. Yeah, I forgot about that thing where you can specify arbitrary argument lists and arbitrary keyword arguments. So the argument lists would be, well, argument lists. They don't have any keys attached to them. They're positional. But the keyword arguments parameter does actually have keys attached to each name, sorry, attached to each value. Give me a second. Okay. All right. Okay. Example usage, so and so, so and so. Fine. Going back to this. So let's do scale factor equals 2, PPI equals 144. I can adjust all of that later. Where is the export option? Now, okay, it says browser renderer here. I'm not doing the browser render thing. I do want to look into this though to see what the options are. Like, who knows? Maybe I don't need to. Um, Wait, it says here to support displaying charts with interactive features in non-browser environments. The browser renderer automatically opens charts in browser tabs of a system web browser. Okay, I could look into this. But then how is it a non-browser environment if it's anyways opening it up in a system web browser? I didn't understand what's going on here, but okay, we can move on from that. Then manual save and display, saving Altair charts. So this is how we do our saving. We display the chart and then there's JSON. Now, you know what? Let's stick with this example because I'm not getting too much about the like how it's meant to be done from Altair's side. So what I'll do is, because I have VL convert installed manually, I'll import this. So VL convert VLC, um, VL spec O1 equals so and so, and then down here. So this is the code that's going to be generated by our save function, and then we want to do PNG data equals so and so Vega to PDF. It's Vega Lite to PDF, right? Yeah. Okay. Vega Lite to PDF. Um, no, it's Vega Lite to PNG. I don't remember if I wrote PNG or what. Okay. Anyways, all right. VL spec equals VL spec and scale equals 2. Right. Width open chart.png binary. What is, hold on. Why are my fans going crazy? Okay. All right. So this is being written as binary data, and then we pass in this. Not writable, it's write. Right. Then we do not need to print this out. We don't need this. We do need that. Where have I specified? Oh, there. So it's supposed to be imgo1.png. That's going to be our image. Now let's work on a quick example over here. Okay, so we have the saving option, right? I know that we need to save. Okay, how are we getting chart.json? Yeah, I need to find out how we are getting chart.json. Um, Altair chart objects have a chart.save method, which allows charts to be saved in a variety of formats. You have the JSON format, HTML format. I didn't know that was an option. I didn't know that was an option. I thought we were limited to just JSON. Offline HTML support. I had no idea this was an option either. And then we have this. Wait, we have this? You're joking. You're joking, dude. Let me see if this works just like out of the box. Um, if this works, then like that's that. You know, our problem is solved. We don't need to worry about any of the other stuff. I still have to read this. Oh, it says here additional dependencies are required to save charts as images by running the JavaScript code necessary to interpret the Vega Lite specification and output it in the form of an image. Then there's something called Altair Saver. Altair Saver was used in Altair 4 and earlier versions. It's no longer maintained and got superseded by Convert, which provides a superior user experience and performance. VL Convert is what we just installed. Now, I need to find out if this is implicitly using VL Convert or not, if chart.save is implicitly using VL Convert or not. So we're going to get a quick example going. Okay, we have our data frame. And actually, yeah, let's go along with this example. Okay, we're going to create another data frame, df02 equals pl dot data frame, create the data frame here. A is list. Oh God, I can't read that. Is that three C's, three D's, and three E's? Okay, I think so. Okay, C. I didn't know this was an option, like creating a list in this way. That's cool. Um, okay, then B is 274.126, 274.126, 847. And I think we are good. Okay, when using Altair, datasets are most commonly provided as a data frame. As we will see, the labeled columns of the data frame are essentially, no, are an essential piece of plotting with Altair. Okay, then we have the chart object. Um, import Altair as alt, chart equals alt.chart. Okay, where do we put that? Let's put that here or here. Um, chart equals alt.chart data. It's not data, it's df02. All right. The fundamental object in Altair is the chart, which takes a data frame as a single argument. So far, we have defined the chart object, but we have not yet told the chart to do anything with the data. That will come next. Encoding and marks. With this chart object in hand, we can now specify how we would like the data to be visualized. We can now specify how we would like the data to be visualized. This is done via the mark attribute of the chart object, which is most conveniently accessed via the chart mark, via the chart dot mark method. Oh, okay, the various mark methods. Okay, so chart dot. Actually, would it let me go to the next line? No, I don't think it would. I think it's going to throw an error. Python can be a little picky about that kind of thing. Um, though there are situations where, as you can see here, it does let you go to the next line, but then in certain situations it can be picky. I don't remember if this is allowed. Like let's try it from here. Dot mark underscore point. It's not working here. Let's try it up here. It's working here. Okay, that is unfortunate. I do want to see if I can apply that this implicit, I forgot what it's called, implicit concatenation thing. So like I did this here and then yes, I can. Holy shit. I'm so glad that I discovered this. So real quick, this thing that I'm doing here, let me just comment this entire thing. Okay. This is useful for implicit. I forgot the specific term that's used there. But the the gist of it is that you can use parentheses to divide an expression across multiple lines. In the past, you would have had to do something like using a backward slash, a backslash, basically. You would have had to use a backslash to break up a statement into multiple lines, assuming your formatter wasn't, already letting you do it. Because Python is it's picky about how things are placed. It's picky about indents. It's also picky about how statements are broken up across multiple lines. So when statements do get long, then you have to find a you have to find the right way to break it up. And previously, I knew about the backslash thing. So if I had like a long string, I would type something like okay, let's say this is a sentence, and let's say I wanted to for whatever reason break it up into another line, then I would go like this. And to be honest, I wouldn't usually use that for strings. I would usually use that to break up actual expressions, bigger expressions. So because of how cluttered the code can get when you're dealing with multiple um, how do I what examples do I give? Because one example I'm able to think of right now, which I can actually show, is in my what was it called? The virtual Stream Deck thing that I was working on. That was a Python project, and for the UI, it was using Streamlit. So I was coding the UI in using the Streamlit library, and a lot of times, state related stuff would be accessed through an indexing mechanism that they had set up. Additionally, that words. Oh my God. Additionally, there are a bunch of other things that get accessed using an indexing sort of mechanism. Not necessarily always integer-based indexing, but like indexing in the sense like you look at polars, for example, to index like I don't know a column or something. I don't remember too much. Not polars. What is it? Pandas. You look at pandas, for example, there's a bunch of stuff going on within square brackets in order to do various operations. So your expressions can get pretty long in that way. And I believe like by default, if you try to break it up, it doesn't let you break it up. The formatter would try to break it up in a way that Python will allow, but just breaking up the statements, you don't have like the most convenient way of doing it. And that is where this kind of thing can be useful. In the past, you would have been using backslash to do this, but now you can just do it in this way. So I can write this is a sentence. I'm going to make the line intentionally long so that I'm actually giving the formatter a reason to leave this leave this long expression as it is. This is a sentence. This is another sentence. Um, this is yet another sentence, and this is another. So this is a pretty long string, as you can see. I'm going to add a space to the end of that, and I'm going to yank this and paste it a couple of times. Now, what this does is this will, if I save this, you can see the formatter hasn't tried to squash it. On the other hand, if I wrote something like, let's say ABC, and then DEF, and then GHI, you can see they're pretty short, right? I'm writing it in this way, and uh, the formatter will actually, not the formatter, but like the linter will accept it as valid, but then the formatter is gonna squash the thing because it fits within that small space. Um, so yeah, that was a bit of a tangent. I'm glad that this works, and I'm glad that I learned about this recently. Okay. Uh, to be honest, I don't need to do this though. I mean, I did it, but like, I don't need to. Um, let's get rid of this as well. And hold on. There. Chart mark point. Okay. All right. So there's a bunch of options here. Um, okay. With this chart object in hand, we can now specify how we would like the data to be visualized. This is done via the mark attribute of so-and-so. Okay, that's done. Um, which is mostly accessed from so-and-so methods. For example, we can show the data as a point using mark point. Wait, what is this? Oh, okay. Okay, here the rendering consists of 1 point per row in the dataset, all plotted on top of each other since we have not yet specified positions for these points. Oh, that so I could have rendered this out as, you know what? Okay, we can experiment with that. Actually, would I have, yeah, I have access to an encode method. What does this return though? Are we able to see the, oh God. Okay, this returns a chart, and then I can save the chart to so and so. Yeah. Okay. All right. Um, okay, to visually separate these points, we can map various encoding channels or channels for short. Oh, encoding channels or channels for short to columns in the dataset. For example, we could encode the variable a um, of the data with the x channel, which represents the x-axis position of the points. This can be done straightforwardly via the chart.encode method. Okay, x equals a. Oh, that's interesting. The formatter broke this up for me manually. Okay, cool. I'm not complaining about that. Um, and now if we render this out, so I haven't seen the thing yet. I'm working with slightly broken knowledge here. I guess further from this point we can just do chart.save, right? Chart, not chart. Oh yeah, it's chart. Chart.save. Um, we provide a path img01.png and then a literal saying png. So is that it? I think we should be good, right? Wrong. Wait, there. Um, okay. So it did its thing and it was slow. I'm guessing here it tried to do the thing from Python, not from Rust. So I think that might be part of the reason why it was slow. Was the image created? I think it was created, right? Let's open up Yahtzee here. Yes, we have our image created there. The image didn't render. I wonder if that has something to do with the way that WesTerm operates here. So let me try doing this. Yeah, okay, okay. Yep, it is. Hold on, hold on. Where is it being rendered? Is it being rendered? It's not being rendered properly. It's there though. Like the thing is there. It's just that yeah, there we go. Okay. So that is our graph. That's interesting. Yep, yep. That is interesting. What it's doing there, I'm not sure. But we have our chart being rendered. We can additionally give it a Y channel. Um, I don't think running it from Python should cause an issue, but it could be causing an issue. That's the chart. Okay, okay, all right. So we have our chart rendered here. Okay, so we've gotten started with this officially. Um, okay, aside examining the JSON so and so, they haven't gone into. Actually, I think the reason they haven't gone into exporting the image is because I think the assumption is that we are running this in something like Jupyter Lab or I forgot what the middle one was, or VS Code. So in VS Code, if you're running, a Jupyter notebook, or basically the idea, I think here the assumption is that we are running this inside a notebook that has the ability to capture whatever is created by this encode function, and then plot the thing or render the thing or whatever. Because like even in matplotlib, you don't need to explicitly call like a show function. You can just do ax.bar, ax.plot, or however that is, and as soon as you call that function, it displays the image for you. Okay, all right. You know what? I think I think that's going to be it for today's stream. Unfortunately, a shorter stream today. I mean, fortunately, I managed to stream for at least an hour. I had some stuff to do because of which I couldn't start the stream earlier. Hopefully tomorrow, though. Hopefully tomorrow I'll start the stream earlier. I don't know what we're going to be doing tomorrow. I don't know if maybe I'll just stick with this. I'll stick with the Altair thing, and we're going to be learning a bunch of data visualization. Or I might stick with the polars thing, and we'll be learning I have to freshen up on polars first and then continue learning the basics of polars. I have been making progress with my knowledge base tool, and I'm gonna continue making progress with that off stream. But I am making progress with it, so I'm happy about that. I've started using both the clap and inquire crates. Clap is for getting command line arguments from the user, and inquire is for giving the user prompts of various types to get input from the user when the program is running. I've now started using both of these crates in my project, and so far I'm loving it. So far I'm definitely loving it. Um, I'm gonna continue making progress with that. After that, I have the dot files program to work on as well, and that I guess is also good. That's not going to involve user prompts. It might involve clap though, so it might involve command line arguments. I'll see, because there's a bunch of like directory traversal that I have to do. Not so much directory traversal, more so going and capturing the exact files and exact directories that I tell it to, and I'll be defining them like in a TOML file. So all of that will be straightforward. Um, but yeah, I'm excited. I'm excited to start working on all of these various Rust programs, and I like the progress that we are making here as well. This progress is going to carry forward in both the data science stuff and in the machine learning stuff, because I don't think after this I'm going to be going back to either Matplotlib or Pandas. I'm going to stick with Polars and now Altair. Okay, but that being said, that's going to be it for today's stream. Zainab, thank you very much for stopping by and hanging out. Anyone else who might have been lurking in the chat, thanks for hanging out. Um, yeah, dude, I think that's it. I hope you guys have a nice day, and I'll see you all next time. Peace.